A couple of more things. Let's start lecture number 4. A couple more things about the sets. Okay, so number 1, the first thing is, so A union, where is that? Special character. Okay, so A union B is equal to B union A. I'll be using U. And A intersection, special character for intersection. No. And A intersection B is the same thing as B intersection A. Okay, I hope it makes sense. If you draw those things, I'm pretty sure you'll understand what I'm talking about. Next. So A union B, right? And that gives us a set. So if we also do a union with some kind of C, it will be exactly the same thing, right? As if we just did a B union C first, and then created a union with A second, okay? Hope it makes sense. What else? The same thing with intersections, right? So for example, if I have something like this, so A intersection B, and if I do intersection with C next, it will be exactly the same thing as if we do it in a different order, right? So if we do B intersection with C, and then we do intersection with A, right? As a result, you will get exactly the same set, exactly the same intersection. Moving on. If hold on. No. So A union A is equal to A intersection A is equal to A. Okay, hope it makes sense. Now A union B, okay, is a subset. Right. No, hold on. No. Sorry. A intersection B is a subset. Special character. Okay. So A intersection B is a subset of A, right? And it's also is a subset of A union B. Okay, cool. Hope it makes sense. Again, if you have any doubts about that, you can just draw a couple of circles, and you will see how they're all true. Number 5. A minus B becomes a subset of what? Of A. A union with the empty set. Special character is what? Is A. And A intersection with an empty set. What do you think that'll be, right? So if you have any set, and if you do intersection with an empty set, that still becomes an empty set. Okay, last one. A is a subset of B if and only if A union B is equal to B. Okay, so A is a subset of B, right? What does it mean? That means A as a whole is included inside B, okay? And that's only possible when A union B, since A is already inside of B, right? A union B becomes B itself. And that's possible if and only if A intersection B is what? So if I have a small circle and I have a bigger circle and that small circle inside of that bigger circle, what the intersection would be? That would be A, right? If and only if A minus B is what? So if I have a smaller circle A, bigger circle B, that smaller circle is included into B completely, right? So what if I do like A minus B? It will be nothing. It will be empty set. Cool. Okay, let's stop here. Hope it makes sense. Please prepare them. Just make sure you know these properties for the quiz. And now we'll get to the book. Okay, so everything I told you about, everything up until this point, I gave it from my personal knowledge and some notes, right? And now we get to the book, chapter number 1. We started with this. The first chapter is finite automata. If you remember, we introduced it. We gave the formal definition of a finite automata. Yeah, perfect. Yes. So this is a formal definition of a finite automaton. Okay. Now I'm gonna give you an informal definition. So kind of it's supposed to be easier to understand, but I don't think it actually. I don't think it's true. I think it's too difficult to understand, as well as everything in this class until we get into the practice. Okay. Once I'll draw those things, I'm pretty sure you guys understand what I'm talking about. Okay, so informal definition of a finite automaton. Okay, so a finite state machine, or FA, or finite automaton, is a device. Okay, so first off, that's informal definition, right? A finite state machine, or FA, and we'll be calling that FA, is a device that recognizes a collection of strings. Okay, it has 3 components. Am I recording? Yes. Okay, it has 3 components. Okay, so number 1. So remember again, formally it's a 5 tuple, right? But here it's like informally it has only 3 components. Number 1, input tape, which contains a single string. Number 2, a sensor or a head. We'll be calling that head, okay? But it's but you can call it sensor, which reads the input string one symbol at a time. And number 3, memory, which can be in any one of a finite number of states. Okay. Okay, so we speak of the current state of automation. Okay. Next, the final state for a string is the state the automation is in when it finishes reading the input. Okay, the final state for a string is the state the automation is in when it finishes reading the input. Okay. Does it make sense? Probably not. But let's keep going. So here's the procedure. So how the FA operates, right? So here's the procedure again. Number 1, set the machine to the start state. Number 2, if end of string, then halt. Number 3, read the symbol. Number 4, update the state according to the current state symbol read. And number 5, go to step 2. Okay, cool. So again, you probably don't have to think about much what we just read. right? Let me draw you something. Let me draw you something first, and then I think it'll make much more sense. Okay, so here's how the FA approximately, here's what it looks like. We'll be using blue. Okay, the size will be this. Okay, so we draw states using circles. Okay, so let's say that's one state. Let me draw like 3 states. Okay. Okay, so we draw states using circles. Then, so a set of these states is called that Q, capital Q. That's a set of states, right? Those states usually have names. So we'll call them like A, B, C. The usual name for the capital letters. And then we have so-called transitions, which are basically arrows between the states. Okay, so for example, A can go to B, B can go to C. Okay, C, so A can also go to itself. Okay, then C can also go to itself twice. Okay, and now there is one state, and it's also like in the formal definition it's called Q0. There is one state in this entire thing which is called the start state. That's basically where the machine is operating from the very beginning, and that state is denoted with the arrow, like this. Okay, so you're gonna have like no matter what kind of FA you're looking at, the first thing which you need to think about is where is the start state? Where do you start processing the string? Okay. Next, each one of these arrows has a label, okay, and it's usually a symbol from the alphabet. In our case, the alphabet will contain only 2 symbols, 1 and 0. Okay, that's it. So for each of these arrows, we're going to have 1 symbol, okay, from that alphabet. For example, here we're going to have 1. Let me draw this. Here we're going to have 0. Here I'm going to have 0. Here I'm gonna have 0, here I'm gonna have 1, and there is one more transition from B back to A, and that symbol is 1. Okay, perfect. So that's what, like with the drawing of FA or DFA finite automaton looks like. Okay, and now here, yes, and the okay, next also at least one of the states, well, sometimes no states, but usually at least one of the states, it's usually marked with double circle. For example, in this case, in our case, it will be C, like this. Okay, double circle. That means that's going to be an acceptance state. In a formal definition, it's called F. Okay, so here's how it's going to work. You have an FA and you also have a string which you're trying to process. Again, what does FA do? FA recognizes a string, which means that FA basically say like, hey, I'm recognizing this string I'm not recognizing. Okay, so the whole purpose of FA is to recognize a string, right? And basically, like, you have a string, you have an FA, you run this string against the FA, the automaton, and at the end, that FA automaton tells you, hey, this string, like, I do not know what that is, it doesn't belong to me. Or it says like, hey, I like this string, it's my string, kind of it belongs to me, so I recognize this string. Okay, it's kind of similar to, like, imagine if I start speaking Russian to you and you will not be able to recognize that, right? So the words I'll be saying, they will not be in the English language and you will not be able to understand them. So kind of similar to that, any kind of finite automaton recognizes some strings and does not recognize some other strings. So it recognizes some words but does not recognize some other words. Kind of, again, similar to regular language, like English language, for example. Okay, so again, in order to do the whole magic, we need an FA, which is described like this, like using a graph or a table, and a string. So, for example, in our case, let's talk about the string. I don't know. So the string would be, let's do 101001. Okay. Now I'm going to yeah. So like that, this part of the section, this part of the lecture, it will be very, very important. I'll be explaining how this processing works, so please pay attention to that. Everything which we'll be discussing later will be based on this particular, the next 5 minutes, basically. So kind of your, it's very important, like your future in this class will depend on these 5 minutes. Ready? So here's how it's gonna work. Okay, so basically at the very beginning, we are located in the state A. Okay, why? Because it is a start state. Why is it a start state? Because this arrow points here. Okay, so we're currently located over here, and then after that we start reading symbols. Start reading symbols from this string. Okay, for example, the first character we're reading, so we read it one by character by character. So the first thing we're gonna do, we're gonna read the first symbol from left to right, which is 1, right? When we're reading 1, when we're reading any symbol, or like 1 in this case, but whenever we're reading a symbol, we need to find an arrow going from A for that symbol. Okay, for example, in this case, an arrow on, from A on 1 goes back to A. Okay, so we're kind of creating a loop, and then we're coming back to A. After that, we see, so like when we consume 1, okay, we're basically like having a loop, and when, then we come back to A. After that, we see 0, so we need to consume 0, and then we need to go to kind of follow the arrow, we need to go to another state, possibly another state, where that 0 leads us to. For example, in this case, let's say we read 1, okay, now we're reading 0. From A on 0, we transition to the state B. So now we're currently in the state B. Okay, perfect. So we can kind of erase this too, right? Next, reading 1, okay, but we're located in the state B. Perfect. So when we're located in the state B, on 1, where do we go? We go back to A. Okay, so then after that, we're located at A. Perfect. After that, we read 0, right? And we kind of transition to where? To B. So we transition from A to B on 0 over here. Okay, perfect. After that, we read the next symbol 0, right? So we're going to transition from B on 0 to where? To C. Okay, perfect. Read 0. And then now we're located at C. We read in the last symbol 1. Okay, so what does it do? It loops back to C. Okay, so we kind of transition from C to C, basically like not doing anything. Okay, and that's it. So at that point, we have nothing left to be read. We read the entire string, and then we need to make a decision. Do we accept the string, or do we recognize the string or not? And here's how it works. If, after reading the entire string, the state we're in is accepting, which means, in other words, if it has double circle, right? In this case, we accept the entire string. That means, hey, that's a word from the English language. Where I understand that, I recognize this, I accept it. Thank you so much. Okay. If at the end of reading the entire string we end up, for example, in B or in A, but not in C, in this case we reject it. We're basically saying, hey, okay, cool, we were able to read the entire thing, perfect, but at the end we did not end up in the accepting state. We reject it. Sorry. Whew. Hope it makes sense. Okay. Okay, perfect. Now, let me do the following. I'm gonna give you the string, and I want you kind of to think for a while, maybe to pause the video, and let me know if this string is going to be accepted or not. Okay, I'm gonna give you some kind of little very long string. Okay. Well, let's do this like this. Okay, so I want you to pause this video for until you finished, and then we'll come back. 1, 2, 3. Okay, so let me know what you let me know what you think. I really hope that you concluded that this string is going to be accepted. Okay, and of course you can. Well, I guess, how do you do that? Okay, so when, let's see. So when you read 1, you're on A. You read 1 more 1, you're on A. Let me raise this. So when you read 1, you're on A. You read 1 more 1, you're on A. When you read 1 more 1, you're on A. When you read 0, you go back to B. When you read 1, you go back to A, read 1 on A, read 1 on A, read 0, go to B, read 1, go back to A, 0, go to B, read 1, go back to A, 0, go to B, read 1, go back to A, 0, go to B, 1, go to A, 0, go to B, now 0, go to C. From C, read 1, stay on C, read 1, stay on C, okay? And now at the end we end up staying on C. That means we're accepting, okay? And of course, there is sometimes there is a much simpler way of discovering. So if a string belongs to this language, if a string will be recognized by this FA, and in this particular case, by looking at this FA, can you kind of guess what kind of strings will be accepted and what kind of strings will be rejected? So what you need to notice is this. First off, the alphabet is 0, 1, right? So on this string, you cannot have anything apart from zeros and ones, okay? That's kind of number one thing which you need to notice. Number two, what needs to happen to the string such that the FA will reach state C? Well, okay, so now hold on. That's too early. So number two, check out the accepting state. There is only one accepting state. It's state C, okay? And the question is it possible to get out of the accepting state? Is it possible to get to accepting state and then for some reason to come back? Right? The answer is no. It's impossible. Once you got to C, there is no transition back to A or no transition back to B, right? Or A. So whatever you read in 0 or 1, you will always be at the state C. Okay, make sense? Perfect. So what does it mean? That means once you reached state C, you will definitely accept 100%. Okay. So the next question is, what needs to happen to the string such that the string will be accepted, such that will reach the state C? What needs to happen? Bam, bam, bam. The answer is we need to have 0, 0, or in other words, 2 zeros in a row. If we have a string which has 2 zeros anywhere in the string, 2 zeros in a row, in that case, we'll definitely get to the state C and we'll accept it. If we have all ones, or 1 0 1 0, or 0 1 0 1 0 1 0 1, right? Yeah, we will not get to the state C. Okay. So basically, if you show me any kind of string without even trying to kind of digest, without trying to understand like which goes where, I'll be immediately able to tell you if that string will be accepted or not. How? I'll just look for 2 zeros in a row. If I don't have like 0 0 anywhere in the string, no, definitely not going to be accepted. Make sense? Hope it does. Okay. A couple more things. Yeah, so let's maybe try to understand what was written like kind of above, right? So how the FA operates, right? Sets the machine to the current state. That's what we did, right? If it is the end of the string, right? It's possible that the string is empty, right? So the string does not contain any symbols. Okay. In this case, we hold and we look at like is the start state already accepted or not? Okay. So if that's not the case, read the symbol, right? They just keep reading the symbols. Update the state according to the current state. Your symbol, according to the current state and symbol red. Right? So basically, you know where you are at, you know what symbol you're reading, and then you kind of transition to one of some states. Okay? And after you do that, you go to step 2, which means you come over here, right? And you kind of reevaluate the situation. Is that the end of the string? If yes, then you stop, then you halt, and you look at the state you're in, trying to think if it is you kind of checking if it is accepting or rejecting. If it's not, then you read the symbol, and then you kind of like there is a for loop. You see, like I guess while loop. So you just keep doing this until you reach the end of the string. Okay. So FA, any FA, acts like a Boolean function, right? For any FA, certain states are designated to be accepted, and the remainder are reject state. The remainder is the reject states. Okay. And if A accepts the input string if the final state is an accept state. Otherwise, it rejects the input string. Okay. So again, it's like a Boolean function, 1 or 0, right? It gives you like either true or false. So you have an FA, you have a string, you run the string against the finite automaton, and it gives you either true or false, either accepted or rejected. That's it. Kind of, there is nothing in the middle. Okay. I'm gonna draw another FA for you, right? And then we will, I'll ask you to tell me what you know about this FA. Okay. Let's clear this. So it's one state, another state, okay? So this guy is the start state, and we'll call it, let's give a name. So that's going to be our A, that's going to be our B, okay? So A transitions to itself, kind of loops to itself, right? Also A can go to B, B can also go back to A, and B also can transition itself. Okay. Out of these two states, B is the only one which is accepting, right? And now let's think about the labels. Okay, so A loops back on itself on 0, and that's actually how it should be pronounced. Okay, so we transition from A to B, right? On, for example, on 1. We transition from B to A on 1, and we transition and we loop B loops back on itself or to itself on 0. Okay, so now I want you to look at this FA and kind of think about what kind of strings is that going to accept. Okay, so pause this video and then think about it. Okay, so one of the ways I would suggest approaching that, I mean, like unless you immediately see what kind of strings it accepts, one of the ways kind of to give yourself a couple of hints. Here's what you can do. You can basically write a bunch of strings and kind of think about what strings, like of those strings, right? What kind of strings is that accepting or rejecting? So just a couple of like 3, 4, 5 absolutely random strings. I don't know, 1, 0. 1 0 0 1 1 1 1 0 0 1 0 1 0, something like this. Okay, so 1 0, does that accept that? 1 0 1 0, okay, and then it stays at B. Okay, it does accept. 1 0 0 0 1, okay, so 1 0 0 0 1 comes back to A, then finishes up there, right? So A is not an accepting state, so it rejects it. And then 3 ones, 1 1 1, okay, perfect, so that accepts it. Now 0 0 0 0 rejects, okay. Now 0 1 0 0 1 0, okay, stays at B, accepts. Okay, so basically you can see that the only way, like the only way you can get from A to B is on 1, right? So kind of zeros don't make any difference at all. Because if you're already in B, like you can have like, I don't know, like billions of zeros, you'll always stay in B. If you're in A, you can also have like huge amount of zeros, you'll always stay in A. Okay, so that's why kind of the number of ones only matters, nothing else. Okay, and now we can see that if we have 1 1, we accept. If we have 1 2 ones, then we reject. If we have 3 of them, 1 1 1, right? Then we accept. If we have 4, 1 1 1 1, then we reject. So basically the answer is this string accepts all strings of zeros and ones with odd number of ones. That's the right answer. Okay. Let's write it, by the way. Okay, so this FA accepts all strings of zeros and ones with an odd number of ones. That's it. Okay, perfect. Moving on. How about this? How about this? How about this? I'm going to have like this state, this state, this state, and this state. Okay. So A, B, C, D, and now I'm going to have the following transitions. Okay. And a couple of loops. So let's see. Okay. So C is going to be accepting. Okay. Ah, no, sorry, hold on. C is going to be accepting, and about the labels. Okay, so from A to B we go on 0. From B to C we go on 0. From C we'll loop back to C on 0 or 1. Okay, so when there is a comma, it's basically a way to kind of combine the transitions. Okay, so this particular case, it means that C loops back on 0 and C loops back on 1. Okay, so either one of those symbols will make an FA loop back on C, and then D, it's also 0, 1. Okay, so I want you to think for, no, hold on, also there is one here and there is one over here. I think that's it. Okay, cool. So I want you to think for a while. Please pause this video again, and so tell me what kind of strings does this FA accept. Okay, please pause this video. Okay, let's see. So first off, again, how many acceptance states do we have? It's only one, C, right? Okay. So what else do we see? We see that if we have, once we're in C, right, there is basically no way to reject anymore. Once we're in C, no matter what we have, 0 or 1, no matter how many zeros or ones we have after we got into C, we're going to accept, right? So basically, it's not really about the string, it's more about the beginning of the string. So after a certain beginning of the string, like we may have as many symbols, any kind of symbols from our alphabet, we'll definitely go into accept. Okay. Okay, that sounds good. Now let's try to analyze this. You see the state D, okay? We'll be talking about that, but states D and C are so-called trap state. Why trap? Because once you got into those trap states, you cannot get out. For example, once you get into C, you can't really get out. You will definitely accept. Once you get into D, you see, you cannot get out either. So on 0, 1, you'll be just looping back. You will always be rejecting. So, and that's actually creating an interesting point. So you see, kind of like once you make a tiny mistake in your string, right? So once something happens and the string, the FA goes to D, there is no way out. Okay, so that's a very, very strict rule for some strings, right? So again, once you get into D, like you cannot really get to C anyway at all. So if there was a transition from D to back to B, that would mean that there is a kind of a chance. So like if you went to D, right, there is still kind of a chance that you will get to C. But when this particular situation, once you got to D, right, you made a mistake and you're definitely not going to win this game. Okay, so what needs to happen for us in order to reach C? Okay, So in order to reach C, the first symbol of our string, what should it be? It has to be 0, right? Because if we get the first symbol as 1, we'll get into the trap state and we'll lose. Okay. Okay. So the first string the first character has to be 0. From 0, from A we transition on to B. Okay. From B again, what should we have in order to transition to C? We should have 0, right? If we get 1, we'll just go to the trap state and we'll lose the game. Okay. What does it mean? That means this FA accepts all kind of strings with the first symbol being 0 and with the second symbol also being 0 and nothing else. So basically any kind of string of zeros and ones starting with 2 zeros. That's the answer, right? Yeah, perfect. Okay, cool. Sounds good. Awesome. Let's do, I guess, one more, right? And I'll give you the homework then. Let's do one more. One more. Okay, so we're gonna have 3 states. Okay, they're going to be A, again B and C. A is going to be start state. From A we can go to B. From B we can go to C, I think, right? Yeah, from B we can go back to A. And then in terms of the loops, A can loop, C can also loop. Okay, and then from C we can also go to A. Okay, now in terms of the labels, A loops on itself on 1, transitions to B on 0. Okay, B transitions to C on 0. C loops back on 0, and C is actually the only acceptance state here. Okay. Now B goes to A on 1, okay, and C goes to A on 1. Okay. Yeah, that's it. So let me know, again, pause this video and let me know what kind of strings does this FA accepts. 1, 2, 3, pause the video. Okay. Let's come back. Okay, so let's try to analyze. Okay, so where's the acceptance state? Acceptance state is the only one here, and it's C, right? So what do we see here? We see that from C, right, it's still possible to get to A and reject, right? So that means it's not like in the previous case where we would have a trap state, like C accepting trap state, right? So it's not the case anymore. So like once we get into C, it's still possible to reject if you have a wrong character. So it's still possible to get go a wrong route. If you get a 1, you go back to A. Okay. Okay, perfect. So let's see what else is going on here. So if we have 1, right, from the very beginning, we kind of loop back on A. Okay, cool. If we have 0, we go to B, and then if we have 1, then we kind of go back to A. Okay, so it kind of what needs to happen for us in order to get to C? We just need to go from A to B on 0, then we can possibly come back, okay, but still then we need to go from A to B on 0, and then from B to C on 0. Okay, so basically we need to have 1 0, second 0, right, to get to C. And then if we get a 1, we just basically get to the beginning. We repeat the whole pattern. But we can the only reason how we can stay in C if we just kind of loop, right? Okay. So basically, in order to win this game, we can have any number of zeros and ones, right? But at the end, we need to have at least 1, 2, and possibly more zeros. Okay. So in other words, this FA accepts all binary strings, all strings of zeros and ones, with 2 zeros at the end. You can say like, well, what if I have 4 zeros at the end? That's true, but the right definition will be with 2 zeros at the end. Because if I have 4 zeros at the end, then I definitely have 2 zeros at the end as well. Okay. Another way of thinking about it is this. So let's think about state B. Okay, so how can we get So if I'm in state B, what does it mean? That means that the symbol I read before getting into B was what? Was 0. Okay? What if I'm in state A? Okay, what does that mean? That means I'm either at the very beginning of the string, right, because I'm a start state, or the symbol I read before was 1, right, because like I'm here, I'm looping on 1, from B I'm going on 1, from C I'm also coming to A, also on 1, right? So if it's kind of like physical meaning of the state A. If I'm in state A, that means before I read 1. If I'm in state B, that means before I read 1, 0, okay? If I'm in state C, what does it mean? That means I at least read 2 zeros before. From A to B, from B to C. Maybe more zeros, but at least 2. At least 2 zeros, right? So it's possible that I read more zeros because I actually looped back a couple of times on C. Okay, hope it makes sense. Perfect, so what I want you to do, I want you to read the book. I want you to read it basically the first chapter. Let's do up until if accepts alternate. What is it? Okay, let's do until page number 8. Page 8. Please read that. And yeah, so at the end, please do the at the bottom of the page 8, do the for you to do exercise. Okay, so definitely read it. Definitely understand like all of those examples, and at the end of the page 8, do the for you to do. Perfect. Yeah, so please expect the homework to be due on Monday. I'll see. Let me know if you have any questions. Again, I know this material can be tough to understand. We definitely need to schedule tutoring sessions. Let me know if you have any other questions. I'll see you guys later. Bye bye.